Hello everyone. Today I'm going to be presenting on the topic solar photovoltaic system. This topic is from the subject renewable energy power plants. I am Kritika Tan from 6th semester Computer Science and Engineering Department. So let's dive into the topic. So what are solar photovoltaic systems? Solar photovoltaic systems or PV systems convert sunlight directly into electricity using semiconductor materials. These systems are essentially part of the renewable energy landscape, contributing to reduce greenhouse gas emissions and depending on fossil fuels. Solar PV systems are composed of several components working together to harness solar energy and converting it into usable electrical power. The basic components of a photovoltaic system includes solar cells, modules, panels, arrays, inverters, and mounting structure. We will discuss about all the systems, all the basic components of our solar photovoltaic cell in the upcoming slides. So let's get into it. Let's look at solar cell fundamentals. A solar cell, also known as a photovoltaic cell, is the fundamental unit of a PV system. It is made from a semiconductor material, typically silicon, that exhibits photovoltaic effect, generating electrical current when exposed to sunlight. Looking at the picture, we can see there is a picture of a solar cell. When it is exposed to sunlight, there is an anti-reflective coating and there is a front contact, there is an emitter. When the solar cell is exposed to sunlight, there is electrons and holes in the semiconductor, and there is electrons and holes contact and electric current is generated. So we look at the key concept, the photovoltaic effect, the process by which light photons are absorbed by the semiconductor material, causing the release of electrons and creating an electric current. Semiconducting material, usually silicon, monocrystalline, or polycrystalline, although other materials like thin film, cadmium, are, are also used. Characteristics and classifications of solar cells. Let's look at characteristics. First characteristic is efficiency. The ratio of electrical output of solar cell to the incident energy in the form of sunlight. Efficiency depends on the material of the technology used. So efficiency is always depending on what kind of material we are using in the solar cell. The current voltage IV curve shows the relationship between the current and the voltage output of a solar cell, provide the insights into its performance and the performance under the different conditions. The IV curve shows the performance of the solar cell under the different conditions we place the solar cell under. The fill factor, FF, a parameter that describes the shape of the IV curve that indicates the quality of the solar cell. The temperature coefficient indicates how the performance of the solar cell changes with the temperature. Now we will look at classification of solar cell. There are majorly three types of solar panel as we can look in the picture: monocrystalline, polycrystalline, and thin film. Let us look at them in brief. Monocrystalline silicon cell. They are made from a single continuous crystalline structure. They offer high efficiency and durability, but they are more expensive. Polycrystalline silicon cell. They are made from multiple silicon crystals melted together. They are less efficient but cheaper to produce. Thin film solar cell. They are made by depositing one or more thin layers of poly, pol- photovoltaic material into a substrate. They are less efficient but can be more flexible and lightweight. So, emerging technologies include organic photovoltaic cell and other cells which are still under development and promise potential improvement in cost and efficiency. Now, let us look at solar cells. Module, panels, and array construction. Solar module. A solar module or solar panel consists of multiple solar cells constructed in series or parallel to increase the voltage and current output. Modules are encapsulated to protect the cells from environmental damage. Construction features. Encapsulation protects the solar cell from moisture, dirt, and mechanical damage. Typically involves materials like EVA, ethylene vinyl acetate. Second, glass cover. A temperature a temporary glass layer that shields the cells from impact and weather. Black sheet protects the rare surface of the module. Frame, often made of aluminum, provides structured rigidity and mounting points. Solar panel. A solar panel refers to a single module or a group of modules physically and electrically connected to a form of a larger unit. Array. A solar array consists of multiple panels connected together to achieve the desired system size and power output. Arrays can be scaled up to meet specific energy requirements that are typically connected in series, increasing voltage and parallelly increasing the current. This is how a solar cell is made. Solar photovoltaic systems are crucial for generating clean and renewable energy. Understanding the fundamental of solar cells, their characteristics, and the construction of modules, panels, and arrays is essential for designing and implementing efficient solar energy systems. This knowledge allows for optimized system performance, cost effectiveness, and reliability, promoting wider adoption of solar energy technologies. Thank you.